Okay, let's look at example 5. Go ahead and use cups on example 5. Okay, it asks, what is the probability that the spinner will land on a 9? Well, first thing we always need to know, probability. We need to look at that key word. Okay, what do we know about probability? Well, it's the desired outcomes. Let me zoom in a little bit. Check that out. It's the desired outcomes over number of possible outcomes. Okay. Well, how many 9s are there? There's one 9. How many possible outcomes are there? Well, there are how many different sections are there? There are 1, 2, 3, 4, 5 different sections. So the probability of landing on a 9 is 1 out of 5, or 0.2, or 20%. Okay. All right. What's the probability that it will not land on a 5? Actually, you guys go ahead and do example B. You should be able to do this. So go ahead and do this on your own. Hit pause, and then when you're done with it, unpause it. And again, you guys, you gotta hit pause so that you do these on your own and really learn. And if you make a mistake, you can learn from it then. So go ahead and hit pause now and do it. Okay, so the not land on a 5. Really important, the word not. So we have the 1 or 100%, or the 5 out of 5 because there are 5 possible, minus the actual probability that it will land on a 5. Again, we've already gone over several examples of the not. Okay, and that is going to get us 4 out of 5. Or in other words, there are 4 other sections that are not 5 out of the possible 5. And that's going to equal 80%. Okay, or 0.8. You guys can write down the 0.8 as well. Okay. We have talked a little bit about the or. So again, go ahead and try C on your own. Hit pause now and do C. When you're done, unpause it. Okay, it says what is the probability? So again, I'm thinking desired over total possible, and it has the word or. Got and, got to multiply. Got or, add them up. So on this, I need to add the probabilities. Okay, well, let's start with one at a time. Okay, and think about this. Is this one spin or 2 spins? Probability that will land on a 6 or a 7. It's only one spin that we're doing. Okay, so 6, there's only one 6. 1 out of 5 spaces are 6. Plus, well, there's only one space that's a 7. So 1 out of 5, that's a 7. And again, when you add those up, you get 2 out of 5, or 40%. Okay? Again, if you're getting these wrong, mark them wrong in your notes. That way you know which ones to go back and study before the test. You gotta work smarter. Okay, next one. Again, you guys have done this, so go ahead and try this one on your own. Hit pause now. Okay, on this one, we're spinning the spinner 2 times. Okay, so it's a compound event. What is probability that you will spin a 5 and then tells us we got to multiply a 6? Okay. Well, what's the probability of spinning a 5? 1 out of 5. What's the probability of a 6? Well, there's only one space out of 5. Okay, and what do we do with these two probabilities? Because it has the words and then, we know we have to multiply. So that answer would give us 1 out of 25, which is equal to 0.4, which is equal to 40%. Okay? Alright, let's go over this next vocab word, independent, and let's add events here. Independent events. Okay, independent events, okay, are events when one event does not affect the other events. Get that down. All right. Now, let's go back up and look here. If we think about the spinner, if I spin the spinner one time, okay, and then I said, hey, I'm going to spin it again, does my result of the first spin at all affect what my second spin is going to be? And the answer is no. The second spin is totally independent of what I get on the first spin. Okay, so in this, like, I could spin a 6, okay, on the first spin, and then I may ask, well, what's the probability that I spin another 6? Well, does the first spin have anything to do with what I'm going to get on the next spin? The answer is no. So the probability of a 6 on the second spin only is still only a 1 out of 5. Okay, let's say we spun it 2 times. We got a 6, and then I'm asking what's the probability that we get a 6 a third time? Okay, well, if I'm just talking that third spin, okay, the probability of spinning a 6 on the third spin is still only 1 out of 5. Okay, if we're talking about one event, the previous spins have nothing to do with the other ones. It's almost, another example would be, let me go back down here, a coin flip. Okay, does the first coin, if you flip a coin 2 times, does the first flip influence at all what the second flip is going to be? And the answer is no. Each flip is totally independent of the other one. And let's actually get that down. I think a coin flip is a good example to get down. So let's write each coin flip is independent . Okay, is independent of the flip before it. Okay? And we'll go over some more examples of those. We'll see some more. All right. Let's look at E really quickly. What is the probability of spinning a 5 and a 7? Now, read this carefully. A 5 and a 7. You may be thinking, oh, it has the word and, so I just need to multiply those. Okay? But think about this. Read it carefully again. How many times are we spinning the spinner on this one? Okay? We're only spinning it one time. It doesn't say and then a 7. It just says and a 7. So we're spinning the spinner one time. If you spin the spinner one time, can you get a 5 and a 7 in one spin? And the answer is no. It's impossible. Okay? So when it's impossible, we say that the probability is 0. Okay? And let's put a note here that we're only spinning once. I'm going to zoom out a little bit. Okay, we're only spinning once. That's right, impossible to get 5 and 7. It's impossible. You can't get both on one spin. Okay? Alrighty. Let's go on to a deck of cards. Okay, what we found over the years is that most students aren't really aware of what a deck of cards is like. And you may think, oh, I'm pretty familiar with the deck of cards. But you got to know exactly what is in each deck of cards. Okay? Excuse me. So let's go over what you would find in a deck of cards. First of all, there are 4 suits. Okay, there are 4 suits in a deck of cards. Okay? There are hearts. Okay, and make sure you're writing this all the way over on the left side of your sheet. Okay, there are hearts. Now, let's actually write this at the very bottom here. There are 52 total cards. Okay, 52 total cards. Alright, so you have hearts, you have diamonds, you have spades, and you have clubs. Okay. Now, if there are 4 different suits, how many cards of each suit are there? How would you figure that out? You know there are 52 total cards. Okay, there are 4 different suits. So how many cards are there of each suit? Well, you basically divide 52 into 4 different categories. So 52 divided by 4 will give you the 13. Okay. Now, hearts, you may know this. Hearts are red. So let's write all, and let's actually write 13 red. Okay, so there are 13 hearts and they're all red. Okay, diamonds are all 13 are also red. Okay, spades. Okay, there are 13 black. Spades, all spades are black. And same with clubs. All clubs are black, and there are 13 of them. Okay? Now, let's draw a picture, and hopefully your pictures are going to be better than mine on this iPad. Hearts, pretty simple to draw. A heart. Okay, that's what they look like on the card. Alright, diamonds, also pretty simple. Remember, these are red. Okay, all of these are red. Now, a spade gets a little more difficult to draw. It's, just watch how I do this and then you can get down. It's kind of an upside down heart. Okay, but there's a little space there and then it comes down like this. Okay, and again, hopefully yours is a little bit better looking than mine. Okay, but that's a spade. Okay, a club kind of has 3 little half circles on it, and then again it kind of has that little, almost like a tree base. Okay, that's a club. Alright, now we need to know what each suit has. So all hearts, okay, and this goes for all of them. For all of these suits, there is a 2, a 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then there is also a jack, a queen, over a little bit further, a king, and an ace. Okay. Now, these cards right here, the jack, queen, king, okay, those cards right there are often referred to as face cards. Okay. Now, they're called face cards because if you actually look at the card, they have kind of a human being figure on it. Okay, a jack, a queen, or a king actually on the card. That's why they're called face cards, because they have a face on them. Okay. Now, each one of these, again, diamonds, you have the exact same cards. It's just they're still red. It's just they're diamonds. So I want you for each one of these to make sure that you transfer. Again, you're going to transfer all of this stuff, all of this right here, you're going to transfer that down for each one of these. Okay, so go ahead and hit pause now and do that, and then once you're done with that, you can go on to the next part. Okay, let's look at the following examples. Okay, you have a deck of cards. Compute the following probabilities. Alright, this first one is asking the probability of a heart. Okay, well, let's think about hearts. What do we know about hearts? Well, I know that there are 4 different suits in a deck of cards, and hearts is only one of them. So I should know right away that the probability of a heart, again, there's 4 suits, hearts, and let's actually write that in words. So hearts over 4 suits. Okay, so the probability is going to be 1 out of 4. Now, you could also think of it a different way. you could say, oh, well, I know there are 13 different hearts in the deck of cards out of 52 total. Okay, and if you reduce this fraction on your calculator or by hand, okay, that's still going to reduce to 1/4. Okay, all right, the probability of a 5. I want you thinking, how many 5s are there in a deck? Okay, well, there's the 5 of all 4 suits, right? There's the, let's do the suits in order. There's the 5 of hearts, there's the 5 of diamonds, there's the 5 of spades, and there's a 5 of clubs. Okay, so there are 4 5s in the deck out of the total of 52, which reduces to, on your calculator, go ahead and do it quick. Okay, that reduces to 1 out of 13. Okay. All right, next, probability of a 9. Let's actually change this. You guys should have more room on your notes. Let's put and then. Okay, a 7. Probability of a 9 and then a 7. Now, here is the key. Without replacement. Okay, without replacement. Here's what that means, you guys. It means that we're going to do 2 draws, right? We're going to draw 2 cards from the deck 2 different times. We're going to draw a card first, and then we're going to draw a second card. Now, after we draw the first card, are we putting that card back in before we draw the second card? And the answer is no. It's without replacement, meaning we are not replacing that card once we draw it. Okay? So, the first draw, though, we still have the 52 cards. And how many 9s are there in the deck? Well, there are 4 9s out of a total of 52. Okay? Now, and then, what operation do we do with and then? Again, you should be saying these things kind of out loud to yourself. You should have said multiplication. Okay? And then a 7. Okay? Well, how many 7s are there in the deck? There are 4 7s in the deck. Okay? Now, though, keep in mind, okay, how many cards are left in the deck? Well, we already drew 1 card out of the deck. Okay, so now there are only 51 cards left for that second draw. Okay, there are only 51 cards left. So this without replacement, let's put a note. Let's just put a note that did not put first card back. Okay, so when we drew that first card, we did not put it back for the second draw. That's why the denominator changed. Okay, and when you multiply this, you will get 4 out of 663, and that cannot be reduced. Okay, so that's your answer. So the probability of drawing a 9 and then a 7 from a deck of cards is very, very small. In fact, as a decimal, that would be 0.006, or it would only be 0.6%, meaning less than 1% chance. Okay. Now, let's look at the next one. Probability of a 9, and again, let's add the word and then. Okay, a 7, and then a 7 with replacement. So this one's a little bit different. Okay, with replacement. So after we draw the first card, we are actually putting that first card back into the deck. So on that second draw, we're still going to have all 52 cards in the deck. Okay, so let's see. The first one would still be 4 out of 52 because there are 4 9s in the deck out of 52 total. And then tells me what operation? It is multiplication. Okay, and then a 7. Okay, well, how many 7s are in the deck? There are 4 7s. Now, remember, we put the first card back that we drew, so there are still 52 cards in the deck. Okay, when you multiply that out, you get 1 over 169. Okay, that would be your answer to this one. All right, let's look at the next one. An ace of hearts. Well, How many aces are there in the deck? There are 4 aces. But how many of those are actually a heart? Okay. Well, there's only 1 ace of hearts in the entire deck. Okay. So this one would just be 1 out of 52. Okay. Again, there's only 1 ace of hearts in the entire deck, so it's 1 out of 52. Okay. Now, the next one's kind of tricky. Okay. It asks, what's the probability of a 6 or a spade? So how many draws are we doing from the deck? Okay. Should say, well, we're only drawing 1 card from the deck, and we're just asking, what's the probability I get a 6 or a spade? Okay. Well, what's the probability of drawing a 6? How many 6s are in the deck? And you should have said 4 out of 52. Okay. Or tells me, what do I need to do with the probabilities? I need to add them. Okay. Now, spades. Here's where it gets a little tricky. Okay, spades. How many spades are there in the deck? Well, there are 13 spades in the deck. So you may be thinking, oh, it's just 13 out of 52. Here's the problem, though. Okay. The problem is that there is a card in the deck that is the 6 of spades. Right? The 6 of spades. So you cannot say, so the 6 of spades, if we write 13, you're actually counting twice. And let's actually draw a quick picture of the 6 of spades. So 6 of spades would look like this. And mine's going to be pretty ugly because I got to draw really small here. Okay. We cannot count the 6 of spades twice. Again, we cannot count the 6 of spades twice. We already counted it in this 4 because there are 4 6s in there, right? We cannot also count it in the spades. So what we have to do is we have to do 13 minus, okay, 13 minus the 1 card. And let's put a note here that we don't, and I'm going to zoom out so I can write a little bit bigger. Okay, we don't double count 6 of spades. Okay, so that's why we have to, and draw an arrow, that's why we have to subtract the 1. We cannot double count the 6 of spades. Still going to be 52 though, because again, we're only drawing 1 card. We're only drawing once. Okay, so that would equal 4 out of 52 plus 12 out of 52. Okay, and when you add those, it will give you 4, and when you add and then reduce, it will give you 4 out of 13. Okay? Okay, last one we're going to do, and this is a tricky one. Okay, Mr. Irwin has a bag of candy. All right. Okay, it contains 50 Tootsie Rolls. Okay, you guys should be using cups on this. I'm not going to use cups because if I underline all this, it's going to basically cross it out because it's hard to get in between those words on my iPad here. So it contains 50 Tootsie Rolls and 20 jelly beans. Okay, so how many total pieces of candy do I have in there? Okay, right away I should say, oh, well, I have a total of 70 in the bag. Okay, his students told him that they really like lemon heads. So he wants to add lemon heads to the bag. Okay, I'm going to see if I can. He wants to add lemon heads to the bag and make sure the probability. Okay, again, you guys have got to start thinking more about keywords. Whenever you see the word probability, you should be thinking desired over total. Okay, picking the lemon head is 60%. Okay, how many lemon heads should he add to the bag? Okay, how many should I add to the bag? So my answer, again, I always start with the in mind. My answer is, let's just write it out. He should add blank lemon heads. this is going to be my answer. I'm just going to circle it now, and then I'm just going to fill in that blank in a second. Okay. Now, we have to think about this. Okay. I have a total number of lemon heads. The total that I have is 70, right? But I'm adding lemon heads to the bag, so I'm going to increase the total. Well, what does the 70 increase by? Well, it increases by the number of lemon heads that I add to the bag. And do we know how many lemon heads we're actually adding to the bag? Answer is no. So how could we show that we're adding something we don't know to the bag? Well, we show 70 plus a variable. And what variable would make sense for this one? Well, we're adding lemon heads. So let's just use L. Okay. So my denominator, my total is 70 plus the number of lemon heads, which I don't know, that I add to the bag. And my desired, right, we're asking the probability that I pick a lemon head. So my desired is the lemon heads. That's what I want to pick from the bag. Okay. So, and again, this is the most important part of this, is understanding how we actually got that. Okay. Now, we want this whole thing, and don't do this on your paper, don't circle it. We want that whole thing, the probability, to equal what? Well, we want it to equal 60% or 0.6. Okay? So I do want you guys to write this out. You can write the equals 0.6. Okay? Now, I'm going to rewrite it so I have a little bit more room to show my work. L over 70 plus the number of lemon heads that I add to the bag. Okay. Now, you may be thinking, well, how do I solve for L in this one? Okay. Well, you have a fraction on this side. We can actually make this side a fraction. Again, anything we can write over 1. Okay. And then, you guys, this is basically a proportion. We can cross multiply. Okay. I'm going to make that decimal bigger, and then we can cross multiply. Okay. Now, 1 times L is just 1 L, and that equals, now here's the tricky part, we have to do 0.6 times this entire thing. So we show it 0.6 parentheses 70 plus L. Okay. Now go ahead and use the distributive property on that, distribute this, and then rewrite it. Okay, when you do that, you get 1L is equal to, what does that equal? 42 plus 0.6L. Okay. Now I have to solve for L, so I need to start by getting all of my L's to the same side. So I'm going to move this 0.6L to the other side by subtracting, because it was a positive, or plus 0.6L. So now I'm going to subtract 0.6L. And I want the L to go over there with it, which is why I include it. Whatever I do to one side, I have to do to the other. Okay. 1 minus 0.6 will give you 0.4L equals 42. Okay. And then we just, again, finish solving for L. Okay. We're multiplying 0.4 times L, so I need to divide both sides by 0.4. Divide by 0.4. Okay. When I do that, I get L is equal to 150. And L is equal to 150. So that is my answer. I have to add 150 lemon heads to the bag so that my probability will give me 60%. Okay. Now let's take a second to kind of recap what we did. When we are adding things to the bag, no matter what it is, but we don't know how many we're going to add to the bag, we need to show that whatever that original total was, again, you guys don't have to write this, I'm just going to kind of help us recap. Whatever that original total was, plus whatever we're adding, which we don't know how many, so we use a variable. Okay? And then that is also my desired, right? Because I'm adding lemon heads and I want to pull lemon heads from the bag. Okay? And you set that equal to whatever probability it told you. And then you have to use a proportion oftentimes to solve these. Use a distributive property and then solve for L. Okay. Now let's get one other, let's kind of get this down in words because this is our notes. And again, don't just copy this down. Okay? Make sure you're thinking about this. So, if we're going to kind of get down in words what we did. If you add candy to the bag, okay, the new total is the 70 plus the L. And the L is the basically lemon heads added to the bag. Okay? Alright, I think we're going to wrap it up there for this video. If you still have any questions on it, make sure that you write down where you have questions at. Okay? One last thing. As a student helped me realize I made a mistake here, and you guys should have noticed this when you did it on your calculators. But 42 divided by 0.4 is not 150. It is 105. Okay, you guys should realize that because you should be doing it on your calculators. 105. So then make sure that you change this up here as well. Instead of 150, again, it is 105. Thank you.